In this video we are going to discuss about the forces and moments due to controls and control surfaces. So basically we will have a coefficient of lift due to deflection of control surface, and this relationship is for the single fin. We need to take into account that we have integration of fin for 4 fins. So for each fin we have delta CL as given as CL alpha, tau, eta d, k3d and delta, and these parameters such as tau, eta d and k3d, how to estimate them? For to estimate the tau we have this relationship over here. For theta f we can estimate theta f using this relationship. This relationship suggests as CF is basically fin chord length as well as C as the chord length of the or maximum chord length of the fin. So in that way we'll have theta f to estimate using the geometry, and after the geometry we'll have tau estimate using the geometry. So this is all physical geometry property. Then we'll come back to the delta CL, where we need to estimate eta d and k3d. Eta d and k3d we can estimate using the Grabit tool. Now CL alpha in degrees, if you want delta in degrees, then CL alpha in degrees we can estimate. For our airfoil or for our airship, the airfoil is actually NACA 0010. So on this airfoil tools, this is the NACA 0010 airfoil, and we'll have this graph over here, that CL versus alpha graph, and this graph is very well for us. We can estimate CL alpha using this graph. So this is how we can get the CL alpha for our fin or for our airfoil. In that way we'll have CL alpha, tau, eta d, k3d and delta is our variable. So delta CL we will estimate using this. Now we'll go for the other parameters such as the drag coefficients. So change in drag coefficient is given by this relationship over here. Now this relationship will have CFC from the physical characteristics of a fin, and SF SFE both from the physical characteristics of a fin. Delta is our variable here, so based on this we'll estimate delta CD. Now finally the moment coefficient for our airfoil or for our fin, single fin. So this is the relationship for the moment coefficient around the C by 4 or fourth of the root chord, mean root chord. Okay, so now we are in the Matlab environment, and I already have typed all the equations and parameters here. Type all these parameters, include the density if you have not calculated in above direction or in above forces, and after that you need to type these parameters. For CL alpha you can go for airfoil, particular for airfoil in airfoil tools where we can estimate CL alpha. Then we have the estimation of eta d. For the eta d and k3d estimation you can use the Grabit tool, and using the Grabit tool you can create a separate function which will estimate you the eta d and k3d, and based on that we will have the delta CL, delta CD and delta CM. You can directly copy paste or directly type these equations in your Matlab environment and use them as it is. So these are initialization of these variables here. We are setting the initial value 0 for all 4 cases. In that case we'll have this 4 times loop, and in that case we can use all the force equations which is given over here, and the moments equation which is also given over here. Now forces and moments equation we can use, and based on forces and moments equation we'll have total force and total moments for our vehicle at different deflection of the individual fin. Individual fin can be deflected in symmetric direction as well as in the non-symmetric direction. If it is in the symmetric direction, then there will not be any yaw or and roll of the vehicle, but if it is non-symmetric, then there will be yaw as well as roll in the vehicle. A tau c parameter, and tau c parameter is basically all 3 forces and all 3 moments. So total tau c is, this is how we calculate. ultimately right now what we want to check is the natural response of the system. So if we want to check the natural response of the system, we will not have any control surface deflection. So to avoid the control surface deflection, we will completely comment these lines of code. Now these lines of code is commented. Now after that we will remove this commented section over here and use this as a control surface deflection. Since we want the natural response, the all the forces and moments due to control surface will be 0. Now our vehicle's control forces and moments are calculated.